Hello, everyone. My name is Andrew DeLay. I'm Director of Distributed Systems Engineering here at Wolfram Research. And today I'm going to talk to you about Wolfram Application Server. It's something new we're cooking up for you for basically another way to bring your Wolfram language content to the web. So what is Wolfram Application Server? Well, Wolfram Application Server is a platform for hosting active web content developed with Wolfram language. Kind of features being scalable, highly available, stateful, RESTful architecture, containerized using Docker, and built using managed cluster technology, in our case, Kubernetes. So basically, it's a modern server architecture for deploying Wolfram language content at scale. So why might you want to choose that? Well, I mean, if you're familiar at all with some of our various web offerings, some of you may have used or familiar with Web Mathematica. Uh, we also have now an open source web server, a very basic web server. Uh, we also have Wolfram Cloud and Enterprise Public Cloud, and basically where application server sits is kind of in the middle between these two. So on the one hand, you have a basic, you have a very simple web server that you can get. Um, hosts one kernel, one web server. It's good for trying stuff out, or maybe hosting a very small application that it's useful, but it doesn't necessarily have to scale or have the availability. On the other end, you've got something like Enterprise Public Cloud, which is another way to host content, but it also offers you the Wolfram language notebooks, interactive sessions, and a whole host of features for letting people, use Wolfram language online and using the full sort of whole suite of notebook online. If you don't need that much, yet you still want to host some kinds of Wolfram language content, particularly things like APIs and forms, which I'll show in a minute, then this is a thing for you. In particular, if you need to host these in a situation where you're going to have a lot of usage, a lot of load, or it's a mission critical application, you want to make sure that that's always going to be available, that that it's not, that if there's a problem that, the cluster management system is going to keep this thing running for you. It's going to give you, your high availability solution. So that's kind of the reason why maybe you choose Wolfram Application Server relative to some of these other products that that we also offer. So in talking about Wolfram Application Server, I just want to go over a few key concepts that'll help you understand how it works and kind of understand a little bit later when I demonstrate some of the tools for using Wolfram Application Server. There are basically three main things that kind of are, concepts or things that are part of the server. The first thing that I'm going to talk about is a resource. A resource is really simple. That's the thing, that's your actual code, or it could be, something like HTML or other static resources. These are the things that are going to be served up by the Wolfram Application Server to your end user. So it could be active web elements, which are things like API function that actually are, computed using Wolfram language. You can also host static content, like I said, like HTML, so that you can even, if you want to, you can build a whole website inside of Application Server. It isn't, I wouldn't necessarily go that far because it's optimized really to serve Wolfram language content, but you can add to that. The second concept is something we call an endpoint. So the resource is something that is served up, but the endpoint makes it addressable. So we've separated out, the content from the resource locator. So when you define an endpoint, you map a path externally that your customer can use to the resource itself, and that is nice because we'll see how you can use resources and endpoints to sort of make things more convenient for doing things like versioning or fixing bugs or going back and forth between different versions of an application. Um, and then finally, we have the node file. The node file is any file that lives on each of the nodes, or in the case of Kubernetes world, they talk about pods. Each instance of an application server, you may need to have resources that are co-located. I mean, for instance, if you have Wolfram language packages that you want, the kernel wants to read those, is going to want to read those from a file system that needs to be on the actual hardware or in the virtual hardware that is running the application server, so that you would use a node file. Now, a node file is something that is not directly accessible by a customer. It's sort of internal use stuff. So these are the three sort of key concepts to help you understand what Wolfram Language Server, Wolfram Application Server is doing. This is the general architecture of the application server. The heart of it is what we call the active web elements server. This is built on top of what we're calling web kernel. This is sort of the evolution of the same technology that we've been using to power Web Mathematica. So we can, if you've used Web Mathematica before, we can support MSPs, and we can also support one of what we call our more modern way of developing web content, things like API function, form function, etc., HTTP response. So we have a kernel manager embedded in this application, this active web element server, and this is what your users or your customers are talking to in order to get content from you. Now, in order to support making and deploying content onto the application server, we have several supporting microservices that allow you to basically deal with that various kind of content I talked about. We have something called the resource manager, which provides an API for creating and modifying and removing resources. We have an endpoint manager, which has an API to allow you to create and remove endpoints to map to your resources. And then we have a node files manager for creating and distributing node files. In the back end, although you don't ever actually interact directly with these things, we have to have a storage service, which is an abstraction over persistent storage. It can be, we have several choices there. If you're on Amazon, that could be your Amazon S3. If you're on your own hardware, we have we can run something called Minios, which sort of emulates S3 and then provides a sort of an object store. Again, you don't interact directly with that, but you need persistent storage, and these various components talk to that. We also have what we call the streaming service. Again, this is sort of the communication hub. Basically, this entire application is driven by messages. So as you create resources and create endpoints or node files, you put them in the storage, then you send messages, and then the active web elements server is able to get those messages and know what's on, what's available, and be able to know where to find various resources that it needs. So you put this whole thing together. That's Wolfram Application Server. When all these pieces are working, you're able to create and deploy and present to your users Wolfram language content. So let me just start with a very simple demonstration. Let me just of some of these various features. So we have a Packlet. We load this Wolfram Application Server Packlet. It defines a service interface, so it's using our service connect and service execute functions. So when we create this object, basically this is recording information about the server you're on, and I'm currently talking to our internal test server. And right now, yeah, there's nothing on it because I cleaned it up. So let's go ahead. So right now I have basically a server with nothing on it. I'm going to go ahead and just deploy a really simple application. It's the pretty much your obligatory hello whatever program, the first program we learn in any language. And notice it creates what's called a service deployment. Now, if I call this information, I can call information on that service deployment object, and it tells me various things. So you notice I created an endpoint called hello. I created a resource, which I put under in a subdirectory, so people know it's me. This is the resource type in this case is an active web element because it's an API function. It means that the kernel is going to do processing on it, and things like MIME type we don't have to worry about. Pool name, the default is public. It is possible to configure application server to run multiple pools. If you want to divide up your workload between multiple pools in the kernel manager, you can do that. Not necessary, so we just pick out the default. And also you can set a timeout. If there's concern about whatever you're deploying being a long-running computation, and maybe you want to, it's possible for users to input data that would cause a very long-running computation. You can, of course, set a timeout here so that it won't run forever. And just show you that this is working. So I send out a query, and you'll notice that in the query I set name it's to world, and we got back hello world. I can do the same thing if I go to a web browser. And you'll notice, again, give it a parameter, get hello world back. So that's being served up by the Wolfram Application Server. So if you want to get, that's getting content onto your Wolfram Application Server. It's one step, so it can be just that easy. Now, there we go. Give it a little bit more details. So we also have some API functions for looking at various information about things. So I noticed I'd set up this hello endpoint. So we have a endpoint information. This gives me a little more information. It's hello, and this tells me the resource that it is pointing to. I can get information about the resource itself. Again, we saw this before. I can actually get the contents of the file. So this is the little string contents, hello world. And that's basically it. So since I'm done with this one, it was a trivial application. If I want to clean it up, I can actually just use this. And now I've removed that from the server. So now I'd like to go through the process in a little more depth, give you a little more fine-grained control over various parts of this. So again, I'll use service deploy to create a service. So what this one does is it creates a form where if you enter any sort of date, it will give you back the day of that date. So, okay, modestly interesting. So we try it out here. So and for those of you who are interested, I was born on a Sunday. Okay, so now if I like, maybe I want to have an alternate way, an alternate path to getting to that same content. So here I called this endpoint day of week. Maybe I want to call it this day. So if people want to try an alternate way, maybe people want to try this one, or people have different ideas about what that should be, I can add an endpoint, and we'll notice if I go up here, I've gone to this day, it's the same thing. Is it? I don't remember if, yeah, there we go. Bonus points if you know what that date is. It was also on a Sunday, at least in the modern calendar. So we've created two different ways to access the same content by deploying multiple endpoints to the same resource. Right. So there we go. Yeah. Sorry, lost my place. So now that's interesting, but it's not all that, like, you know, let's jazz up this this application just a little bit. I'm going to use some content from Wolfram Alpha. This talk may include optional extras. So I'm going to define this function, you know, about this date. It's going to query Wolfram Alpha and give me some more information about the date, and then return it as an image so that I can display it on a web page. So what I'm going to do is I'm going to deploy this as a resource. Now, and in this case, here's my form page. It's going to use this function. Now, so far I've just created a resource. I haven't created an endpoint, so I can't yet access this new thing. Now, here's a little information about it. Now, one of the things that's interesting and kind of to note is when I deployed this resource, you'll notice when I get the contents here, you see a bunch of this blah, blah. You notice I didn't have to say anything about this function definition. I defined this function, I deployed it, and you'll kind of know in here, you'll notice in here in some various information that we have basically the definition of about this date. So by default, when you deploy a resource, any dependencies that you have will be figured out, and all that code will be inserted into your application, which is quite nice. You know, if you're working in a notebook, you have a bunch of code, a bunch of functions, and you finally kind of get it to what you want. You just have to deploy this function, and underneath it all, we'll sort it all out and deploy everything you need so that when you go ahead and close that. So when we create an endpoint to this, it's just going to work. So notice in this case, I'm going to change the endpoint this day to point to my new resource, which I deployed up here as about day. So this is a different resource than before, but it's going to have, I'm updating the endpoint. So if we go back here, and in this case, if I send the form again, you see that now I get this nice Wolfram Alpha output of, here's the day, so it was a Sunday, some various calendars if you're interested. There's the Islamic calendar for anyone who knows it. How long ago it was, and for everyone who said Battle of Hastings, give yourself 1 point, you are a winner. So look, so now we have a kind of more interesting form, and again, I just deployed a resource, I changed an endpoint, and now I have a different, you know, I have a simple endpoint and a more complex endpoint. Kind of illustrates some of the usefulness of separating the resource from the endpoint, because with the resource, I mean, one of the things you can do, for instance, let's say you want to update, you're working on a new version of some API, and you want to deploy it. You deploy it as, you can maybe deploy, you know, you can deploy the resources with a different name than the previous one, you know, maybe just like resource.1, resource.2, whatever, some convention you want to follow. And then all you have to do is change the endpoint. And if, you know, worst comes to worst, you realize maybe there's a bug in it, or you don't like the way the new API is working, it's just a matter of remapping the endpoint back to the old resource, and you immediately restore your old functionality. So breaking up, you know, there's a lot of convenient things about breaking up resources and endpoints, and it makes it, you know, things like controlling versions of your APIs are one of the things that you get by doing this. Boy, I managed to keep hitting the wrong thing. Let's go to the last slide and go back. There we go, almost done. All right, so far, we've looked at creating content and just deploying it straight from a notebook. Obviously, if you have a more complicated application, something that has a lot of code, and you want to use it, you want to package it all up and then have things access that package, we can do that. So I've created this package. It's not very interesting, but it shows you a package file. It has this function. It's basically the same about this day function that I deployed before, but now it's, you know, sort of done in a nice package with some messaging. And what I can do is I can deploy this package as a node file. And we'll notice now that if I ask for the node files, I'll get this. And now again, this isn't content that your users are going to access directly. What's happening is this package is now being distributed to all the pods in the Kubernetes cluster. And I can deploy a resource. And in this case, I'm going to need to load the package and then call the function. But I'll go ahead and do that. So now notice I'm updating my About This Day resource to have new content, which is a form page that's going to rely on this package for this functionality. Now, I haven't loaded this package into my session because remember what I said, that by default, all the definitions will be copied in and included as part of this distribution. So you want to be a little careful if you're using packages that you don't have them, that you clear your context before you deploy this, and then of course you fully qualify the name here. Or there is an option that you can include in this I haven't tried this before, but if you do this, that's another way. It says don't actually try to get the definitions. Let's see if this works. It seems to work good. All right. And now I'm going to reroute my endpoint. Maybe not already. And then we can load this one more time. Talking to alpha. And here we go. So still works. So in this case, I've shown how that you can use a package. I'm not going to demonstrate this here, but obviously the next question is, well, look, I have a very large package. I don't want to have to load it every time, I call my function. I just want every kernel to load that package when when it's initialized, and then I can just use this. And you can do that. It's very simple. We have a convention. If you deploy on a file, in a init.wl or a init.m file as a node file to, I think it's .wolfram/kernel, then that will be loaded. That will be read as a kernel initialization file. So it's possible then to create initialization files so that every time a kernel is created, it's going to load your package. So again, if you have a very large application, you can deploy it as a package. You can then include initialization code that will always load that package. And then when your actual API is served up, it'll all be loaded, warmed up, ready to go. So we've got that covered as well. All right, so that kind of ends the basic features. I've pretty much hit all of the APIs, the main high points of the API, and how you create content and manage it on the Wolfram Application Server. I'm just going to be nice here and clean up.